Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 17 Circles. We have already discussed exercise 17A of Chapter Circles. Today we will be discussing some important points and solve questions from exercise 17B. Hope you all are ready for the session. Let's start. Let us discuss some important results. Here we have the first one. In a circle, equal chord subtends equal angle at the center of the circle. Here we are taking a circle. This is center of circle. I am marking it as O. This is a chord AB and this is a chord CD. Okay. Equal chords means the length of AB will be equal to the length of CD. Okay, whether it is chord or the arc, you can consider the arc AB and arc CD. Okay, length of arc and the length of chord are equal. Now, what does the statement say? Equal chord subtends equal angle at the center. AB subtends angle AOB at the center and CD subtends angle COD at the center. This is angle AOB and this is angle COD. So, according to this statement, the angle subtended by AB at the center will be equal to the angle subtended by CD at the center since both of these are equal in length. Okay. Therefore, angle AOB will be equal to angle COD. Clear? The measure of angle AOB will be equal to measure of angle COD since both these are of equal length. Now, the converse of the statement is also true. If arc subtends equal angles at the center, then the length of arc will be equal. Okay. For example, let us take angle AOB is equal to 50 degrees. Then what is the measure of COD? Given AB is equal to CD. AB and CD are two equal chords or AB and CD are two equal arcs. Then measure of AOB is given. If AOB is equal to 50 degree, what is the measure of COD? What is the measure of COD? COD will be equal to 50 degrees. Correct. COD is also equal to 50 degrees. What is the reason? Angle subtended by equal chords are always equal. Now, if I am giving AB is equal to some 5 centimeter and given that AOB is equal to COD, then what is the measure of CD? If angles are equal, angle subtended by chords are equal, then the length of chords will be equal. Therefore, CD will also be equal to 5 centimeter. Clear? So, this is our first result. In a circle, equal chord subtends equal angle at the center of circle. Center of circle. Remember this. Okay. Second statement. Angle subtended by the sides of an equilateral triangle inscribed in a circle is 120 degree. Inscribed. Inscribed means we have studied this. Inscribed means the triangle comes inside the circle. Okay. This is triangle ABC. Not just the triangle, this triangle is an equilateral triangle. What is an equilateral triangle? A triangle with all sides equal. We call an equilateral triangle. So, here AB is equal to BC is equal to AC. We have studied a result. Now, here we have the center O. Okay. AOB is the angle subtended by AB at the center. Okay. The side BC, which is a chord of circle, subtends an angle BOC at the center and the side AC of triangle ABC, which is a chord of the circle, subtends an angle AOC at the center. Okay. We have studied the result, that is angle subtended by equal chords are equal. Angle subtended by the chords at the center will be equal. Okay, we have AB equal to BC equal to AC. Therefore, the angle they subtend at the center will also be equal. Angle AOB will be equal to BC. BC subtends angle BOC at the center. Angle BOC will be equal to AOC. Angle AOC. Okay. AOB, BOC, AOC. Now what is this total angle? We know the total angle will be equal to 360 degrees. Therefore, we have angle AOB plus angle BOC plus angle AOC is equal to 360 degrees. This is a complete circle. Okay, 360 degrees. Now, if I am taking AOB as some x, we'll be having BOC is equal to x and AOC will also be equal to x because all these angles are equal. Therefore, x plus x plus x is equal to 360 degree. X plus x plus x is 3x. 3x is equal to 360 degree. Then what is the measure of x? X will be equal to 360 degrees divided by 3 and that is equal to 120 degree. Okay. This measure x is equal to 120 degree, which means angle AOB is equal to angle BOC is equal to angle AOC and that is 120 degree. Clear? So, the statement angle subtended by the sides of an equilateral triangle inscribed in a circle is equal to 120 degree. AOB is the angle subtended by AB, BOC is the angle subtended by side BC and AOC is the angle subtended by side AC. Okay, the statement is clear. Now the third result, angle subtended by sides of irregular polygons at the center is given by 360 degree divided by n. Here we have studied that angle subtended by sides of an equilateral triangle. Equilateral triangle is a regular polygon. Equilateral triangle is equal to 120 degree. That is 360 degree divided by 3. Because there we had 3 sides. Now here let us take a square. Square is a regular polygon. All the sides are equal. Now here inside this circle I am taking a square. Okay. This is my square. A, B, C, D. Okay. Here we have center O. AB subtends angle AOB at the center. BC subtends angle BOC at the center. DC or CD subtends angle DOC at the center. And AD subtends angle AOD at the center. Okay. Now, what is the measure of one angle? These are equal chords. Equal chord subtends equal angles at the center. So, we will be having AOB equal to angle BOC equal to angle DOC equal to angle AO. Like before, if I am taking this one as x, all the angles will be x. X plus x plus x plus x, I will be getting equal to 360 degrees. 4 times x is equal to 360 degree. Then what is x? X is equal to 360 divided by 4 and that is equal to 90 degree. Therefore, the angle subtended by the sides of a square. Square is a 4-sided regular polygon is equal to 90 degree. Now, how do we get 90 degree? 90 degree is 360 divided by 4. Here, n value is equal to 4. Okay. The formula is 360 degree divided by n. N value is equal to 4. Why 4? Because it is a 4-sided polygon. Now, when it comes to a 5-sided polygon, that is pentagon. Pentagon is a regular 5-sided polygon. 2, 3, 4, 5. This is a 5-sided pentagon. A, B, C, D, E. Here we have center O. AOB is angle subtended by AB. BOC is angle subtended by BC. COD is angle subtended by CD. DOE is the angle subtended by DE. And AOE is the angle subtended by AE. Okay. Here, how to find the measure of one angle? That is, if I have to find angle AOB, what I have to do? Take the 360 degree and divide by number of sides. Here, what do we have number of sides? we have 5 sides. Therefore, 360 degree divided by 5, which is equal to 72 degree. Now, if I am taking the case of hexagon, hexagon we know is a regular polygon with 6 sides. Okay, here we'll take a hexagon. This is a hexagon A, B, C, D, E, F. This is center O. Will be having angles AOB, BOC, COD, DOE, EOF and AOF. Okay, what is measure of one angle? How to find AOB? AOB will be equal to 360 degree divided by number of sides. In case of hexagon, the number of sides is 6. Okay, therefore 360 degree divided by 6 and that is equal to 60 degree. Okay, if we know the number of side, we can find the number of, if we know the number of side, we can find the angle subtended by the sides of the regular polygon at the center. Okay, angle subtended by sides of a regular polygon at the center is given by, just we have to know this formula, that is 360 degree divided by number of sides. Okay, fourth one, ratio of angle subtended by the chords is equal to the ratio of length of chords in a circle. Here, I'll be taking 2 chords. This is A, B and this is C, D. 2 chords. First result we have studied, the angle subtended by equal chords are equal at the center. Okay, here we have center O. This is angle AOB. Angle subtended by chord AB, and this is angle COD, the angle subtended by the chord CD. Here AB is a small chord and CD is a bigger chord. Okay, when you take the ratio of the length of chords, that is AB divided by CD, just take this figure. Here AOB is a small angle and COD is a bigger angle. So when you take the ratio of the length of sides, that is take the ratio of the length of chords, the ratio will be equal to the angle the chord subtend at the center. Ratio, that is AB subtends angle AOB at the center, angle AOB divided by angle COD. Here if I am taking CD is equal to 2 times AB, that is the length of CD is twice the length of AB. Then how can you find the ratio of AOB and COD? We have AB by CD. AB by CD will be equal to 1 by 2. Okay, if CD is equal to 2 times AB, then AB by CD will be equal to 1 by 2. If AB by CD is equal to 1 by 2, then the measure angle AOB divided by angle COD is equal to 1 by 2. If AOB, let us take angle AOB is equal to some 40 degree, then what is angle COD? In this case, we have angle AOB by angle COD is equal to 1 by 2, which means angle COD will be equal to 2 times angle AOB. Just cross multiplying, we get angle COD is equal to 2 times angle AOB. AOB is 40 degree. I am taking AOB as 40 degree. Then angle COD will be equal to 2 times 40 degree and that is equal to 80 degrees. Okay. So length of sides, the measure we have taken, CD is 2 times AB. If CD is 2 times AB, then angle COD is also 2 times angle AOB. So this is the result. Okay, ratio of angle subtended by the chords is equal to the ratio of length of chords in a circle. It is not necessary that the length of chords are given, even the length of arc will get the same case. If the ratio of angle subtended by the chords is equal to the ratio of length of the arcs, you can take like that. That is arc subtends angles. Okay, let us take an example. In the given figure, the lengths of arc AB and arc BC are in the ratio 3:2. If angle AOB is equal to 96 degree, find angle CAB and ADB. First, to find CAB, where do we have CAB? This angle is CAB. Here what is given? Given arc AB by arc BC is equal to 3 by 2. The ratio of the arc AB and arc BC is equal to 3 by 2. We have studied a result. Okay. The ratio of arc is equal to the ratio of the angle subtended by the arc. We have studied this result. Okay. We are going to use it here. What is the angle subtended by arc AB? AB subtends an angle AOB at the center. Okay. Angle subtended by arc AB at center is angle AOB, and angle subtended by arc BC at center is BC. This is BC and the angle subtended is BOC. Angle BOC. Then what is the relation between AOB and BOC? Arc AB by arc BC is equal to 3 by 2, which means angle AOB divided by angle BOC is equal to 3 by 2. What is the reason? Ratio of angles subtended by arcs at the center is equal to ratio of length of arcs. Okay. So, this is the reason. We have angle AOB by angle BOC is equal to 3 divided by 2. Okay. Then what else is given? The measure angle AOB is given. Angle AOB is equal to 96 degrees. Okay. If AOB is 96 degrees, we have angle BOC is equal to, on cross multiplying, we get 2 divided by 3 times angle AOB. Yes. That is equal to 2 by 3 into 96 degrees. 3 and 96 can be cancelled. Here we get 32 degree. 32 degree into 2, which is 64 degree. The measure of BOC, this angle, is equal to 64 degree. Now what we need to find? We have to find in the first part angle CAB. How to find CAB? CAB. Is there any relation between BOC and CAB? Here when you take this arc or this chord BC, BC subtends angle BOC at the center and BAC on the circumference of circle. We have angle BOC is 2 times angle CAB. What is the reason? Angle subtended at center is twice angle subtended on the circumference. On the circumference of circle. Okay. Then what is the measure of CAB? Angle CAB will be equal to angle BOC divided by 2. BOC we have 64 degrees. 64 degrees divided by 2 and that is equal to 32 degrees. Okay. We got this measure CAB. Angle CAB is equal to 32 degrees. Next we need to find angle ADB. How to find ADB? To find ADB, I am making a small construction, that is, I am joining this A and D and points B and D. Here I will be getting the angle ADB. How to find ADB? Now, this points A, D, B and C touches the circle. Yes, therefore we can say that ADBC is a cyclic quadrilateral. ADBC is a cyclic quadrilateral. Okay. What is the peculiarity with the cyclic quadrilateral? We will be having the sum of opposite angles equal to 180 degree. Okay. That is here ADB and ACB when added, angle ADB plus angle ACB is equal to 180 degree. But we don't know the measure of ACB. If we have ACB, we can find ADB. Now what is ACB? How to find ACB? We have AOB, right? AOB is given in the question. In the question it is given angle AOB is equal to 96 degrees. If AOB is equal to 96 degree, then what is ACB? AOB and ACB are subtended by the same chord AB. AOB is subtended at the center and angle ACB is subtended at the circumference of circle. Therefore, angle ACB will be equal to angle AOB divided by 2, that is 96 degree by 2, which is equal to 48 degrees. Okay, 48 degrees is the measure of angle ACB. ACB is 48 degrees. We got ACB. Now we can find ADB, right? Angle ADB plus angle ACB will be equal to 180 degree. Reason, cyclic quadrilateral, sum of opposite angles is 180 degrees. Okay, ADB we have to find angle ADB is equal to 180 degree minus angle ACB. ACB we know that is 48 degrees minus 48 degrees. Okay, then what is the measure? We will be getting 132 degrees when we subtract. 180 minus 48 degrees is 132 degrees. 132 degrees is the measure of angle ADB. Angle ADB is equal to 132 degrees. Clear? Understood this? Now let us solve questions from exercise 17B. Here we have the first problem, question 1 of exercise 17B. In a cyclic trapezium, the non-parallel sides are equal and the diagonals are also equal. We have to prove it. We have to prove that the non-parallel sides and the diagonals are equal in a cyclic trapezium. How will you get a cyclic trapezium? Here I have a circle and I am drawing a trapezium inside this circle. Okay, so this is a cyclic trapezium. What are the peculiarities of a trapezium? For a trapezium, we will be having two sides parallel. That is, these sides are known as parallel sides and non-parallel sides. These are non-parallel sides. So, when non-parallel sides becomes equal, we call it a isosceles trapezium. Okay, now here let us take this as trapezium ABCD. Okay. In this ABCD, we have to show that the non-parallel sides are equal. Non-parallel sides AD and BC are the non-parallel sides. To prove AD is equal to BC is the first one that we have to prove. Okay. Then we have to prove that the diagonals are also equal. Diagonals AC is one diagonal and BD is the second diagonal. We have to show AC is equal to BD. Okay. Now, in this trapezium, I am taking this angle A as some x. Okay. Let angle A is equal to x. Is there any relation between angle A and angle D? This is a trapezium. Okay. We know that AB is parallel to DC. They are the parallel sides. Okay. AB and DC are parallel. If they are parallel, then angle A and angle D will be the co-interior angles. So, this AD is a transversal in this case for lines AB and CD. Okay. Then angle X and this D will be co-interior angles. What are co-interior angles? Angles that comes on the same side. Okay. And when you take the sum of these co-interior angles, you will get 180 degrees. That is, angle A plus angle D will always be equal to 180 degrees. Reason, co-interior angles. Okay, if angle A plus angle D is equal to 180 degree, we have taken angle A is equal to x. X plus angle D is equal to 180 degree and angle D is equal to 180 degree minus x. We are getting this angle as 180 degree minus x. Okay. Is there any relation between A and C? This is a cyclic quadrilateral. For a cyclic quadrilateral, we know that sum of opposite angles will be equal to 180 degree. Therefore, we can write angle A plus angle C is equal to 180 degree. Reason, sum of opposite angles of a cyclic quadrilateral is 180 degrees. Now, angle A we have taken as x plus angle C is equal to 180 degree. Then what is angle C? Angle C will also be equal to 180 degree minus x. This angle is 180 degree minus x. Okay. Now, again the same thing, that is AB and CD are parallel lines. BC is a transversal. When BC cuts the parallel lines, you will be getting co-interior angles. Yes. Therefore, angle B plus angle C will be equal to 180 degree. Reason, co-interior angles. Okay. We have found the value of angle C. What is angle C? Angle B plus angle C is 180 degree minus x is equal to 180 degree. 180 degrees can be cancelled from both sides. We get angle B is equal to minus x. When taken to the right hand side, we get plus x. Therefore, angle B is also equal to x. Now, what should we show? We have to show that AD is equal to BC. Okay. Since the base angles, these are the base angles. Since base angles are equal, this figure, this trapezium will be an isosceles trapezium. Okay. Since base angles are equal, ABCD is a isosceles trapezium. So, for an isosceles trapezium, we will be having the non-parallel sides equal. Here, AD will be equal to BC. That is, non-parallel sides are equal. Next, we have to show the diagonals are equal. That is, we have to show AC is equal to BD. For that, I am considering two triangles. Consider triangle DAC and triangle DBC. Okay. In DAC and DBC, we have angle ADC is equal to angle BCD. Both of them are equal to 180 degree minus x. Then AD is equal to BC. They are the non-parallel sides. Non-parallel sides are equal. Then DC is equal to DC. Common side. Okay. Then we will be having DAC and DBC are similar triangles. Yes. Triangle DAC is similar to triangle DBC. Okay. Since they are similar triangles and we have AD is equal to BC, DC is common to both, and the angle that comes between these sides are equal, by SAS property we can say that they are congruent triangles or the similar triangles. Now, for similar triangles we will be having AC, that is all the sides equal. Here two sides already we have equal, then the third side should also be equal. Yes, therefore AC will be equal to BD. Okay, that is they are the corresponding sides of congruent triangles. Clear? So, this is how we get diagonals equal. Okay, we are getting diagonals also equal. We have proved that the non-parallel sides are equal and the diagonals are also equal in the cyclic trapezium. Next, problem number 2, question 2 of exercise 17B. In the following figure, AD is the diameter of the circle with center O. Chords AB, BC and CD are equal length. If DEF is equal to 110 degrees, we have to calculate AEF and FAB. AEF. AEF. So, I am drawing a line here. So, this angle is angle AEF. We have to find AEF and one more angle, that is FAB. FAB. This one. Okay. First, let us find AEF. First one, to find angle AEF. So, when you look at this figure, it is given that angle DEF is equal to 110 degrees. AEF is a part of angle DEF. Yes, a small portion of DEF is AEF. Okay, if we are able to find DEA, on subtracting this DEA from DEF, we will be getting the measure of AEF. How to find DEA now? Here, AD is the diameter and we know that the diameter subtends 90 degree on the circumference of circle, or angle in a semicircle is right angle. So, we will be getting this part 90 degrees. Okay, we have DEF is equal to 110 degrees, angle DEA is equal to 90 degree. What is the reason? Angle in a semicircle is right angle. Okay, therefore, we have angle DEF is equal to angle DEA plus angle AEF. Okay, then what is AEF? Angle AEF is equal to angle DEF minus angle DEA. DEF, the total angle is 110 degrees. 110 degrees minus DEA. This portion is 90 degree. 110 minus 90 degree, we get 20 degrees. So, this small angle is 20 degrees. Okay, we have found what angle AEF is. AEF is equal to 20 degrees. Now, the second part we have to find angle FAB. It is a big angle, that is FAB. Here FAB can be written as angle FAB is equal to. What is FAB? FAB will be equal to angle, if I am drawing lines here, that is OB and OC. Okay. So, this FAB consists of FAD and OAB. Yes, OAB, this portion. OAB. Now, how to find OAB? Consider this part. It is given that AB, BC and CD are equal chords. Equal chord subtends equal angles at the center. Yes, we know that. So, here the total angle will be equal to 180 degree. Okay, total angle is 180 degree. Now, this 180 degree is divided to 3 equal portions. Yes, angle AOB plus angle BOC plus angle COD is equal to 180 degrees. Here AD is a straight line. Therefore, the sum of angles should be equal to 180 degrees. Now, we have angle AOB equal to angle BOC equal to angle COD. What is the reason? Angles subtended by equal chords are equal. Okay. Therefore, AOB, BOC and COD are equal. We can write this as 3 times angle AOB is equal to 180 degree. If 3 times AOB is equal to 180 degree, then AOB will be equal to 180 degrees divided by 3, and that is equal to 180 by 3 is 60 degrees. So, we got this portion 60 degrees. So, we got this portion equal to 60 degrees. AOB is equal to 60 degrees. Okay. Now, consider triangle AOB. Okay. In triangle AOB, we have OA is equal to OB. OA is equal to OB because they are the radii of circle. Radii of circle will be of same length. Yes. Therefore, the angles opposite to equal sides are equal. When you take OA, angle opposite to OA, we have OBA. Angle OBA is equal to angle opposite to OB, we have OAB. OAB. Okay. In this triangle, we have angle OBA plus angle OAB plus angle AOB is equal to 180 degrees. Sum of interior angles of a triangle is 180 degrees. Okay, here we have determined the value of AOB. AOB is equal to 60 degree and we have OAB, OBA equal. Therefore, we can write it as 2 times OAB plus AOB is 60 degree is equal to 180 degree, which means 2 times OAB is equal to 180 degree minus 60 degree. What is 180 minus 60? 180 minus 60, we get 120 degree. And angle OAB will be equal to 120 divided by 2, that is 60 degree. So, we are getting this part 60 degrees. Okay, we got OAB 60 degree. Now, we need FAD. Yes, if we get FAD, we can add them and find what FAB is. Angle FAD plus angle FED will be equal to 180 degree. What is the reason? When you consider this figure here, AFED is a cyclic quadrilateral. AFED is a cyclic quadrilateral. For a cyclic quadrilateral, we have the sum of opposite angles is equal to 180 degrees. Okay. Therefore, FAD is this angle and FED is this angle. FED we know it is given in the question. FED and DEF are the same. That is 110 degrees. Now, put the values. Angle FAD plus 110 degree is equal to 180 degree and FAD will be equal to 180 degree minus 110 degree, which is 70 degrees. Okay, we are getting this part 70 degrees. Then what is angle FAB? FAB is equal to angle FAD plus angle OAB. That is 70 degree plus 60 degree equal to 130 degree. Angle FAB is equal to 130 degrees. Clear? We have found the big angle FAB. Okay, next problem number 3, question 4 of exercise 17B. The given figure shows a circle with center O, also PQ is equal to QR is equal to RS and angle PTS is equal to 75 degrees. We have to calculate POS. POS. So, I am joining here. POS is this angle. This total angle is POS. Then QOR, the small angle, and PQR is this angle. So, first we have to find angle POS. Okay, given angle PTS is equal to 75 degrees. Here, when you take this chord PS or this arc PQRS subtends angle POS at the center and PTS on the circumference of circle. So, we will be having POS equal to 2 times PTS. Angle POS is equal to 2 times angle PTS. What is the reason? Angle subtended by arc PQRS at center and on the circumference of circle. Okay, POS is equal to 2 times PTS. Now, what is PTS? PTS is given, that is 75 degrees. Then we get POS is equal to 2 into 75 degree, which is equal to 150 degrees. Okay, we are getting this total angle POS is equal to 150 degrees. Clear? Now the second question, we have to find QOR. Okay, to find QOR, given that PQ is equal to QR is equal to RS, they are equal chords. We know that the angle subtended by equal chords will be equal. Therefore, since PQ is equal to QR is equal to RS, PQ subtends angles POQ at the center. Angle POQ, angle subtended by QR. QR subtends angle QOR at the center. QOR, that is equal to ROS. ROS is the angle subtended by RS at the center. So, the sum of these three angles give us POS. Yes, angle POQ plus angle QOR plus angle ROS is equal to 150 degrees. That is angle POS. Now, since POQ is equal to QOR is equal to ROS, we can write it as 3 times angle QOR. Why have I taken QOR? Because we have to determine QOR. QOR, POQ and ROS are equal. Okay, 3 times QOR is equal to 150 degrees, which implies angle QOR is equal to 150 degree divided by 3, and that is 50 degrees. Okay, we are getting QOR is equal to 50 degrees. This is the second part. If QOR is equal to 50 degree, then we will be having POQ is equal to QOR is equal to ROS equal to 50 degree. Now, third part we have to find angle PQR. PQR. PQR is this angle. We have angle PQR is equal to angle PQO plus angle RQO. That is, PQO is this part and RQO is this part. On adding these two, we get angle PQR. Now, we will separately find both these angles. For that, this angle belongs to triangle POQ. Yes, consider triangle POQ. In this triangle POQ, we have angle POQ. Yes, what is POQ? POQ is equal to QOR is equal to ROS is equal to 50 degrees. Therefore, we can write angle POQ plus angle OPQ plus angle PQO is equal to 180 degree. Sum of interior angles. Interior angles of a triangle is 180 degrees. Okay, we know the value of angle POQ. Now, what about OPQ and PQO? They are equal. Why? Because OP is equal to OQ. Since OP is equal to OQ, radii of circle. Okay, radius of circle will be of equal length. Now, these are sides of the triangle. We know angles opposite to equal sides are equal. Therefore, OP. Opposite to OP, we have PQO. Angle PQO is equal to, opposite to OQ, we have OPQ. OPQ. Okay. Reason, angles opposite to equal sides are equal. Okay. Then we can write this. We can rewrite this as 2 times angle PQO plus angle POQ is equal to 180 degrees. Since these two angles are equal, I am writing this as 2 times PQO. Putting the value 2 times angle PQO plus 50 degree equal to 180 degrees. Okay. Then 2 times PQO is equal to 180 degree minus 50 degree. What is 180 degree minus 50 degree? 180 minus 50, we get 130 degrees. 2 times PQO is equal to 130 degree and angle PQO is equal to 130 degree divided by 2. What is the value? PQO is equal to 130 by 2, that is 65 degrees. Okay. Similarly, when you consider triangle QOR, you will be having OQ is equal to OR, sides OQ is equal to OR, therefore angles opposite to equal sides are equal. OQR and ORQ will be equal. That is angle RQO equal to angle ORQ. Angles opposite to equal sides. Okay. Then we have determined QOR. QR is equal to 50 degrees. That is, we can write angle QOR plus 2 times angle RQO is equal to 180 degree. I have taken 2 times RQO because RQO plus ORQ can be written as 2 times RQO because they are equal. Now put the value. QOR is 50 degree plus 2 times angle RQO is equal to 180 degree. 2 times RQO is equal to 180 degree minus 50 degree, that is 130 degree, which implies angle RQO is equal to 130 divided by 2, that is 65 degrees. Okay, here we got a 65 degrees and RQO is also equal to 65 degrees. What we have to find? We have to find PQR. PQR is the sum of PQO and RQO. Angle PQR is equal to angle PQO plus angle RQO, and that is equal to 65 degree plus 65 degree, which is equal to 130 degrees. Okay, we get 130 degrees. Clear? Next, problem number 4, question 5 of exercise 17B. In the given figure, AB is the side of a regular 6-sided polygon and AC is the side of a regular 8-sided polygon inscribed in the circle with center O. Calculate the sizes of angle AOB, ACB and ABC. AOB. AOB is this angle, then ACB. ACB, this angle, and ABC. ABC, this angle. Okay. Now, it is given that AB is the side of a regular 6-sided polygon. Regular 6-sided polygon is a hexagon. Okay. We have AB here. Then what is the angle subtended by AB? Since AB is side of regular 6-sided polygon, angle AOB will be equal to, here the total angle will be 360 degree. Since AB is side of a regular 6-sided polygon, we will be having other sides here, we will be having 6 sides. Therefore, 360 divided by 6. When you find 360 divided by 6, we will be getting the angle AOB. 360 divided by 6, that is 60 degrees. Okay, we get angle AOB is equal to 60 degrees. Now, the second one, we have to find angle ACB. How to find ACB? Where do we have ACB? This is ACB. This arc AB or the chord AB subtends angle AOB at the center and ACB on the circumference of circle. Yes. Therefore, angle ACB will be equal to angle AOB divided by 2. What is the reason? Angle subtended by an arc at the center is double the angle subtended on circumference. Okay, on circumference. So, you will be having angle AOB is equal to 2 times angle ACB. Therefore, ACB is AOB divided by 2. We have found AOB. AOB is equal to 60 degree. Therefore, angle ACB is equal to angle AOB divided by 2, and that is 60 degree by 2, which is equal to 30 degrees. We get 30 degrees. Now, the third one we have to find angle ABC. ABC is subtended by chord AC on the circumference. So, when I join this, I will be getting angle AOC subtended by chord AC at the center. Now, what is AC? AC, it is given that AC is a side of regular 8-sided polygon. Then, what is angle AOC? Since AC is a side of regular 8-sided polygon, we get angle AOC equal to total 360 degree will be divided into 8 parts. Okay, divided by 8. What do we get? 360 degree divided by 8 is 45 degrees. So, this measure is 45 degrees. Angle AOC is 45 degrees. We have angle AOC equal to 2 times angle ABC. Reason? Angle subtended at center is twice angle subtended on circumference. Angle subtended on circumference. Now, we will put the value. Angle ABC will be angle AOC divided by 2. AOC is equal to 45 degrees. 45 degree divided by 2 is just equal to 22.5 or 22.5 degrees. 22.5 degrees. Clear? So, we have determined all the 3 angles AOB, ACB and ABC. Next, problem number 5, question 6 of exercise 17B. In a regular polygon ABCDE inscribed in a circle, find the ratio between angle EDA and angle ADC. Here, take a circle. This is a 5-sided polygon which is inscribed within the circle. So, here I am drawing a 5-sided polygon A, B, C, D, E. This is the center of the circle. Mark it as O. Now, we have AB, BC, CD, DE and AE equal. Yes, this is a regular 5-sided polygon. AOB is the angle subtended by AB. BOC is the angle subtended by BC. COD is the angle subtended by CD. And DOE, angle subtended by ED. When you take AE, angle subtended by AE will be equal to AOE. Okay. Now, we have to find EDA and ADC separately. Where do we have EDA? EDA. I'm drawing a line here. This angle is EDA. So, here EA, this line EA subtends angle EOA at the center and EDA on the circumference of circle. Okay, we'll be having angle EOA is equal to 2 times angle EDA, or angle EDA is equal to angle EOA divided by 2. But we don't know the value of EOA. How to find EOA? EOA. Now, this regular 5-sided polygon, the angle 360 degree will be divided into 5 equal half. Yes, therefore, angle EOA will be equal to 360 degree divided by 5. What is 360 degree divided by 5? We get 72 degrees. Okay, then we can find EDA. EDA will be equal to 72 degree divided by 2, which is 36 degree. What is the reason? Angle subtended by an arc at center is double the angle subtended at the circumference. At the circumference. Okay. So we got EDA. Now what we have to determine? We have to find ADC. ADC. ADC is this angle. How to find ADC? Now I am considering a chord AC. Okay. This chord AC subtends angle AOC at the center and ADC on the circumference of circle. Therefore, AOC will be equal to 2 times angle ADC. Okay. Now, what is AOC? Angle AOC is equal to angle AOB plus angle BOC. AOB, BOC, COD, DOE and EOA are all equal and the value will be equal to 72 degrees. Right? Therefore, AOB is 72 degrees and BOC is also equal to 72 degrees. 72 plus 72, we get 144 degrees. AOC, angle AOC is equal to 144 degrees. If AOC is equal to 144 degrees, what is the measure of ADC? Angle ADC will be equal to angle AOC divided by 2. Reason? Angle subtended at center is double the angle subtended at the circumference. Put the value, angle ADC will be equal to, AOC is 144 degree divided by 2, which is 72 degree. We need to find the ratio of angle EDA and ADC. EDA, we have determined EDA is equal to 36 degrees. 36 degree divided by ADC. ADC is equal to 72 degrees. 72 degrees. Then what is the ratio? 36 by 72, we get 1 by 2. 1 is to 2. 1 is to 2 is the required ratio. Clear? Understood this? Next, problem number 6, question 8 of exercise 17B. In the figure, O is the center of the circle and the length of arc AB is twice the length of arc BC. If angle AOB is equal to 108 degrees, find CAB and ADB. We have to find CAB, this angle, and we have to find ADB. To get ADB, I am joining these points AD and BD. So, this is ADB. What is given in the question? Length of arc AB is twice the length of arc BC, which means the ratio of AB and BC. Arc AB divided by arc BC will be equal to 2 divided by 1, because AB is equal to 2 times BC. Okay. The angle subtended by an arc at the center. Here AB arc when considered, the angle subtended by AB at center is AOB and by BC at center is BOC. Okay. The ratio of the angle subtended by arcs at the center will be equal to the ratio of the length of arcs. Okay. Arc AB, we have angle AOB. Angle AOB divided by arc BC subtends angle BOC will be equal to 2 divided by 1, which means angle AOB is equal to 2 times BOC, or angle BOC is equal to angle AOB divided by 2. In the question it is given that angle AOB is equal to 108 degrees. This is 108 degrees. If AOB is equal to 108 degrees, what is BOC? BOC will be equal to 108 degree divided by 2, which is 54 degrees. Okay. This part BOC is 54 degrees. Now, what we have to find? The first part we have to find CAB. CAB. Is there any relation between BOC and CAB? When you consider this arc BC. BC subtends angle BOC at the center and BAC on the circumference of circle. Therefore, angle BOC is equal to 2 times angle CAB. Angle subtended at center is twice the angle subtended on circumference. Okay. Therefore, BOC is equal to 2 times CAB. We need to find CAB. Angle CAB is equal to BOC divided by 2. Put the value BOC we have determined, which is 54 degrees. 54 degree divided by 2, that is equal to 27 degrees. This part CAB. This part is 27 degrees. Okay. CAB is 27 degrees. Now, the second part of the question, we have to find angle ADB. How to find ADB? ADB, here we have ADB. Now, consider cyclic quadrilateral ACBD. ACBD. Okay, we know that the sum of opposite angles will be equal to 180 degree. Angle ADB plus angle ACB equal to 180 degrees. But we don't know the value of ACB. How can you find ACB? There is a relation between ACB and AOB. Angle AOB will be equal to 2 times angle ACB. Same reason, angle subtended by an arc at center is twice the angle subtended on the circumference of circle. Okay, AOB is equal to 108 degrees. Angle ACB will be equal to angle AOB divided by 2. AOB is 108 degree divided by 2, which is 54 degrees. Okay, we are getting ACB, this part 54 degrees. If ACB is equal to 54 degrees, we are having angle ADB plus 54 degrees is equal to 180 degrees. What is the reason? Sum of opposite angles of a cyclic quadrilateral is 180 degrees. Okay. Therefore, angle ADB is equal to 180 degree minus 54 degrees. That is 126 degrees. Okay. We get ADB. This angle ADB is equal to 126 degrees. Clear? Here we have the last problem for today. Problem number 7, question 9 of exercise 17B. The figure shows a circle with center O. AB is the side of a regular pentagon and AC is the side of a regular hexagon. Find the angles of the triangle ABC. Here you can find ABC. Is BC the diameter? No, right? BC is not passing through the center O. Therefore, BC is not the diameter. Given that AB is the side of a regular pentagon. Pentagon has 5 sides. And AC is the side of a regular hexagon. Hexagon has 6 sides. First, we'll find the angle subtended by the sides of pentagon and hexagon at the center. Okay. When you take this AB is a chord of the circle. Okay. AB subtends an angle AOB. AOB at the center. What is the measure of AOB? Angle AOB will be equal to, total we have 360 degree, and similar to AB, for a pentagon there are 5 sides of same measure as that of AB. Therefore, the angle 360 degree will be divided into 5. Yes, 360 degree divided by 5, and that is equal to 72 degree. AOB is 72 degrees. Okay. Now, AC is the side of a regular hexagon. Hexagon has 6 sides. Therefore, the angle subtended by AC at the center, angle AOC, this angle AOC will be equal to 360 degree divided by, there are 6 sides. Yes, therefore, divide by 6, and 360 by 6 is equal to 60 degrees. Okay, we need to find the angles, all the angles of triangle ABC. In triangle ABC, we need to find angle ABC, then angle ACB and angle BAC. Okay, first let us take ABC. ABC. This angle. How to find ABC? Now when you take ABC, ABC is related to AOC. Why? Because AC, this chord AC, subtends angle AOC at the center and ABC on the circumference of circle. Therefore, we have angle AOC is equal to 2 times angle ABC. What is the reason? Angle subtended at the center is twice the angle subtended on the circle, on the circumference of circle. Okay. Therefore, we have angle ABC equal to angle AOC divided by 2. We know what angle AOC is. We have determined AOC is equal to 60 degrees. Okay. This angle AOC is equal to 60 degrees. Therefore, 60 degree divided by 2 and that is equal to 30 degrees. Okay. We found ABC. ABC is 30 degree. Now, angle ACB. This angle. How to find ACB? Same as how we found ABC, we can find ACB. Okay. ACB is an angle that is subtended by the chord AB. And AOB is subtended by chord AB at the center. Therefore, we will be having angle AOB is equal to twice angle ACB. Okay. AOB we have determined. AOB is equal to 72 degrees. Then, angle ACB is equal to angle AOB divided by 2. 72 degrees divided by 2 and that is equal to 36 degrees. Okay, 36 degrees. This part is 36 degree. Now, in triangle ABC, 2 angles we have determined. We know the sum of all the interior angles of a triangle is equal to 180 degree. Therefore, angle ABC plus angle ACB plus angle BAC is equal to 180 degree. Sum of interior angles of a triangle is 180 degree. Clear? Now put the values. What is ABC? ABC is equal to 30 degree plus ACB. ACB is 36 degree plus BAC we have to find. BAC is equal to 180 degree. 30 plus 36. How much do we get? 66 degree. 66 degree plus BAC is equal to 180 degree, which implies BAC is equal to 180 degree minus 66 degree. What is the final answer? 180 degree minus 66 degree, we get 114 degrees. Okay, angle BAC, this one, this angle is equal to 114 degrees. So, we have determined all the 3 angles of triangle ABC. Okay, that's all for today. In today's class, we have studied some important results from the chapter circles. We have solved questions from exercise 17B. Hope you all enjoyed this section. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.